So look here. So the induced dipole moment and the orientation dipole moment. So the orientation dipole moment is given like this. What is K? I have explained it is the Boltzmann's constant. So it is Boltzmann's constant R divided by N0. So the total polarization is equal to, first one is induced polarization. So induced polarization d minus 1 d plus 2 m by rho 4 by 3 pi n 0 alpha, where alpha is the polarizability, plus the orientation polarization 4 by 3 pi n0 mu square by 3 kt. Are you getting? Right. Now, this entire term can be written as A. This entire term can be written as B by T. Look here. B by T, where B is equal to, look here, except T, you can take all other terms. 4 pi n0 mu square by 9k. So in all this, mu is the only thing you don't know. Therefore, can be written as mu is equal to, if you substitute the values of Avogadro number 3.14, k the Boltzmann's constant, you are getting mu is equal to 0.0128 square root of b into 10 power minus 18. So this is called Debye's explanation. Debye. What Debye has found out, mu has a linear dependence with t. Is it right? Mu has a linear dependence. So this is B. So B comes over here. So mu has a linear dependence with 1 by t for molecules with permanent dipole moments. See, I have already told you the molecules without a permanent dipole moment, their polarization is a temperature independent. The polarization does not change with the temperature. But according to Debye explanation, the mu has a linear dependence with 1 by t for molecules with the permanent dipole moment. Look here, I don't know why this window comes over there. I don't know why this window comes over here. Anybody knows? Okay, right. Let us see. I'll stop share and share it again. Some undesirable window is coming over there. Okay, now it is not coming. Okay, right. Now look. Look here. So Debye explanation. The questions may be asked. Explain the Debye approach to the polarizability. See, the Debye explanation is for the molecules with the permanent dipole moment has a linear relation with 1 by t. Without permanent dipole moment, there is no relation between the dipole moment and the temperature. Hence, whether a molecule is a polar or non-polar can be found out using the theory of Debye. And this theory was found to be in accordance with the experimental data. That is what I have presented in the form of a graph. Look here, I am going to plot polarization versus 1 by T. If I am getting a horizontal line that shows that this 1 by T does not have any role in the polarization. Therefore, for neutral molecules like methane, neutral molecules like carbon tetrachloride, you are getting a horizontal line. If it has a linear relation with the polarization, 1 by T and the polarization are linearly related, then you will be having a line like this with a positive slope. So if you are getting a positive slope, then these molecules are having permanent dipole moment. Therefore, whether a molecule is a polar or non-polar can be found out by the theory of Debye using this experimental data. Actually, this experimental data were found to be in accordance with the theory explained by Debye. This is the Debye's approach. But you know one thing, these are all the things applicable for gases. What about the solids and liquids? For solids and liquids, say P1, 2, 1, 2. Normally, whenever number 1, 2 or A, B are given for binary systems. So, in a few classes, you will be discussing this phase rule or phase construction of a phase diagram and the solutions and the mole fraction and all that you are going to study. If you are given these numbers 1, 2 or A and B, 1 or A will always for the solvent. The 2 or B are always for the solute. So the first is a solvent, second is a solute. All right. So when the solids or liquids are taken, you have to dissolve the substance in solvent, and the solvent should preferentially be a non-polar substance. It should preferentially be a non-polar substance. Therefore, P1, 2 is a D minus 1, D plus 2 into N1, M1 plus N2, M2 divided by rho, the density of the solution, where D is the dielectric constant of the solution, because the solvent will have a different dielectric constant and the solute will have different dielectric constant. This is for the entire solution. So rho is also density of the solution, whereas N1, N2 are the mole fractions of a solvent and a solute. M1, M2 are the molecular weights of the solvent and the solute. But here you have to understand, I am mentioning N1, N2, but in some other textbooks it is mentioned as X1, X2, because a small x is the normal expression for mole fraction. What is mole fraction? It is the number of moles of a substance divided by total number of moles. So say for example, the mole fraction of the solvent is equal to number of moles of the solvent divided by number of moles of the solvent plus number of moles of the solute. So this is how it is calculated. Therefore, for solids and liquids, it is calculated in this manner. But you should always have the understanding in your mind, the polarity or non-polarity of the molecules can be found out experimentally according to the Debye theory, which proves that the dipole moment is having a linear relationship with 1 by T for molecules with a permanent dipole moment, and also molecules without a dipole moment. The dipole moment does not have any relation with the temperature. So these are all the things we have discussed today, and let us meet in the fourth hour. So so far we have seen, once I would like to repeat all these things. I have seen what is a dipole moment, and how to calculate the dipole moment of hydrochloric acid, HCl, and also why there is a difference in the calculated value and the experimental value that shows the partial ionic character of the molecule. And also I have seen the arrangement of atoms, bond length and bond angle, how they affect the dipole moment of multi-atomic molecules. And also I have seen what is a hydrogen bond and what is the origin of the hydrogen bond, and what are intermolecular hydrogen bonding and intramolecular hydrogen bonding, and how do they affect the boiling point and the solubility of the substances, and how it is affecting the boiling point and the solubility in the periodic approach, and the unique properties of water molecules. And also we have seen what is a bond angle, bond strength and bond energy. And we have also discussed the importance of the hydrogen bond. And also we have seen the electrical polarization and the Clausius-Mosotty equation and the Debye equation, and how they are all differing for solids and liquids. And these are all the things we have seen. With this, I am completing my part in the unit 3. So unit 3 in my part, it is over. So the remaining things in the unit 3 will be dealt by Dr. Baby Marietta. So let us see in the 5th hour with the group theoretical approach to dipole moment and the optical activity. With this, we come to the end of this class, and I thank you very much. Thank you. Thank you. Armasamy will mark the attendance and send it to me.